Dear students, welcome to my classroom. In previous classes of this chapter, we learned what is tangent, what is secant, and what are the properties of tangents, and also how to construct the tangents to a circle from a given point, etc. And in this class, we are going to study about segments of a circle formed by a secant. Segments of a circle formed by a secant. We know that what is secant. A secant is a line which intersects a circle in two distinct points. Here I have a circle, and here PQ is the secant which intersect the circle in 2 points A and B. And here we can observe that this secant dividing the circle into two parts, isn't it? And each part is called the segment of the circle. Each part is called a segment of the circle. And here one segment occupying more area and another segment occupying less area. And the segment occupying more area is called major segment, and the segment occupying less area is called minor segment. And if the secant passes through center of the circle like this, then the circle divided into two equal parts, and each part is called a semicircle. Okay, and we know that area of the circle is pi r square, where r is the radius of the circle, so that the area of the semicircle is half of pi r square. Okay, but how to find the areas of major segment and minor segment? So let us know how to find the areas of segment of a circle. Here I am taking a circle with center O, and xy is a secant which intersect the circle in two distinct points A and B. Let P be a point on this minor arc, and here APB is called minor segment, and Q is a point on major arc. Then AQB is major segment. Now draw radii from O to A and B. OA and OB are the radii of the circle. Now we can observe that the sector OAPB, here OAPB is a sector and OAQB is also a sector. And now sector OAPB is the combination of minor segment APB and triangle OAB, isn't it? Here, this triangle and this minor segment together forming the sector. Okay, so now the area of the segment APB is the difference of area of the sector OAPB and the area of the triangle OAB, isn't it? So the area of segment APB is equal to area of the sector OAPB minus area of the triangle OAB. And we can notice that the segment AQB is the combination of the sector OAQB and triangle OAB. So that the area of segment AQB is the sum of the areas of sector OAQB and triangle OAB. Otherwise, it can be written as area of the segment AQB is equal to area of the circle and minus area of segment APB. By subtracting the area of this minor segment from the area of circle, we get the area of segment, major segment AQB. So, in this way, we can find the areas of segments of circle. So, let us solve the exercise 9.3, which is based on areas of major segment, minor segment, and sectors. Okay. So, the first problem is in a circle of radius 10 centimeter, a chord subtends a right angle at the center. Find the area of the corresponding number 1 minor segment, number 2 major segment. And it is given that use pi is equal to 3.14. Okay. So here a circle of radius 10 centimeter is given and a chord a subtends right angle at the center. We have to find the areas of both minor segment and major segment. Okay. So here we have the circle with center O and AB is a chord of this circle and it is given that the chord subtending right angle at the center. That is, by joining the ends of chord to center, the angle between the lines is 90 degrees. And also it is given that radius of the circle OA, OH and OB is equal to 10 centimeters. And now we have to find the areas of minor segment and major segment. So let P be the point on minor arc and Q be a point on major arc. Now APB is the minor segment and AQB is the major segment. So radius of the circle is OA is equal to OB equal to 10 centimeters and given angle AOB equal to 90 degrees, as it is given that the chord AB subtending right angle at the center. Now the area of this right triangle, area of the right triangle OAB is half into base into height. As triangle OAB is right angle, if we take OA as base, then OB is the height of the triangle, isn't it? So that area of the triangle OAB is equal to half into base OA into height OB. So now by substituting OA is equal to OB equal to 10, then the area is equal to 50. So area of right triangle OAB is 50 centimeter square. And now the area of sector OAPB is, we know that the area of sector is x by 360 into pi r square, where x is the angle of sector and r is the radius of the circle. So area of sector OAPB is x by 360 into pi r square, where x is the angle of sector which is equal to 90 degrees and r is the radius of the sector is OA equal to OB equal to 10. So by substituting these values in this formula, we have x is equal to 90 and pi is equal to 3.14, r is equal to 10. So 90 by 360 into 3.14 into 10 into 10. So 91s are 94s are and 3.14 into 10 into 10 is equal to 314. So this one is equal to 1 by 4 into 314, which is equal to 78.5. So that area of sector OAPB is 78.5 centimeters square. So now we know that the area of segment APB is equal to area of sector OAPB minus area of triangle OAB. Okay. So in this way we can find the area of minor segment APB. So take first one. Area of minor segment APB is equal to area of sector OAPB minus area of triangle OAB. So by substituting the values which you have find area of sector OAPB is 78.5 and area of triangle OAB is 50, we get 28.5. So area of minor segment is 28.5 centimeters square. And second one, major segment. So we have area of major segment is equal to area of the circle minus area of the minor segment. Okay, area of the major segment is equal to area of circle minus area of minor segment. By subtracting this area of minor segment from area of circle, we remains with area of major segment AQB. Okay, so area of major segment AQB is equal to area of circle minus area of segment APB. So we have area of circle is pi r square and area of segment is APB is 78.5. So sorry, area of segment APB is 28.5. So already we find the value of pi r square here as 3.14 into 10 into 10, which is equal to 314. So we can substitute directly 314 in place of area of circle. So this one is equal to 314 minus 28.5, which is equal to 285.5. So area of the major segment AQB is 285.5 centimeter square. Okay. So this is the process of finding areas of major segment and minor segment. So take the next one. In a circle of radius 12 centimeter, a chord subtends an angle of 120 degrees at the center. Find the area of the corresponding minor segment of the circle. Use pi is equal to 3.14 and root 3 is equal to 1.732. So here just we have to find the area of minor segment only. No need to find the area of major segment. Okay. So here the circle with center O and AB is the chord which subtending an angle 120 degrees at the center. Let P be a point on minor arc, as we have to find the area of minor segment. We are taking the point P on minor arc. So here the radius of the circle is 12 centimeter. So that OA is equal to OP is equal to 12 centimeter. So here the angle is 120 degrees. So now radius of the circle is OA is equal to OB is equal to 12 centimeter. And given angle AOB is equal to 120 degrees. Now the area of the segment APB is equal to area of sector OAPB minus area of triangle OAB. So we have to find the both the areas of sector OAPB and triangle OAB, and by subtracting area of triangle OAB from area of sector OAPB, we remains with the area of the segment APB. So now draw OM perpendicular to AB, because here to find the area of triangle OAB, we need the base and height of the triangle. Okay. In right angle triangle, the sides having right angle are base and height. But here we have to find the lengths of base and height. So now first draw OM perpendicular to AB like this. Now, angle AOM is equal to angle BOM is equal to half the angle AOB. That is, as angle AOB is 120 degrees, then angle AOM is equal to angle BOM is equal to 60 degrees, because perpendicular drawn from center to a chord bisects the angle at the center like this. So as OM perpendicular to AB, then OM bisects the angle at O. That is, angle AOM is equal to angle BOM. Both are equal to half the angle AOB, which is equal to 60 degrees. Okay. Now, in this right triangle OMA, we have angle AOM is equal to 60 degrees. So, sine of angle OMA is equal to 90 degrees, angle AOM is equal to 60 degrees. Now, sine of angle AOM, we are taking the trigonometric ratio sine here. Sine of angle AOM is equal to side opposite to angle AOM by hypotenuse. And the side opposite to angle AOM is AM, and here the hypotenuse is OA. So sine of angle AOM is equal to AM by OA, where AM is the AM we have to find here, and OA is the hypotenuse. Angle AOM is 60 degrees. So by substituting these values, we get sine 60 degrees is equal to AM by OA is 12. And we know that the value of sine 60 degrees is equal to root 3 by 2. So root 3 by 2 is equal to AM by 12. And from this, we have AM is equal to 12 into root 3 by 2, which is equal to 6 root 3. So the length of AM is 6 root 3. We know that in a circle, the perpendicular drawn from center to a chord bisects the chord also. So here AM is equal to BM is equal to half the AB. So before that, here find cos angle AOM first. Cos of angle AOM is equal to adjacent side to angle AOM by hypotenuse. And here the adjacent side to angle AOM is OM and the hypotenuse is OA. So cos of 60 degrees is equal to OM by 12. So, and we know that cos 60 is equal to 1 by 2. So this implies we can write half is equal to OM by 12. And from this, OM is equal to 12 by 2, which is equal to 6. Now, the length of AB is equal to twice the length of AM, because here AM is equal to BM is equal to half of AB. Since the perpendicular drawn from center to a chord bisects the chord. So AM is equal to BM and both are equal to half of AB. So AB is twice the length of AM. So AB is 2 into AM, where 2 into, we have AM is equal to 6 root 3 and is equal to 12 root 3. So now we have the base AB is equal to 12 root 3 and the height OM is equal to 6. So the area of triangle OAB is equal to half into base 12 in 12 root 3 into height 6. So this one is equal to 36 root 3 to 6, 6 into 6, 36 into root 3, 36 root 3. And we have root 3 is equal to 1.732. So by substituting root 3 is equal to 1.732, we get 62.352 approximately. So the area of triangle OAB is 62.352. Now the area of minor segment APB is equal to area of the sector OAPB minus area of the triangle OAB. So first we have to find the area of sector OAPB. So area of sector OAPB is equal to x by 360 into pi r square, where x is the angle of sector, which is equal to 120, and r is the radius of sector, which is equal to 12. So by substituting the values, X is 120 and R is 12 and pi is 3.14. So 120 by 360 is 1 by 3, and by simplifying this value, we get 150.72. Now, area of the sector OAPB is 150.72 centimeter square, and area of triangle OAB is 62.352 centimeter square. So that area of the minor segment APB is equal to area of the sector OAPB minus area of triangle OAB. So is equal to, we have area of the sector OAPB is 150.72 and area of triangle OAB is 62.352. So this difference is equal to 88.368. So area of the minor segment is 88.368 centimeters square. Okay. And simply we can say that area of minor segment is area of sector OAPB minus area of triangle OAB. Okay. So to find the area of triangle OAB, we have to find the height of this triangle as well as base AB. So using trigonometric ratios, we find the values OM and AB, and after that area of triangle OAB, and after that area of sector OAPB, and after that area of the minor segment APB. Okay. So take the next one. A car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeters sweeping through an angle of 115 degrees. Find the total area cleaned at each sweep of the blades. This is the question. Here we have to use pi is equal to 22 by 7. So I am drawing the figure for given problem. So this is the mirror of car, and these are the areas sweeping by the blades, wiper blades, and it is given that the length of the wiper blade is 25 centimeters and sector angles are 115 degrees. So we can observe that these two are in the shape of sectors whose radius is 25 centimeters and sector angle is 150 degrees. Now the area swept by two blades is equal to sum of the areas of these two equal sectors. Okay. So area swept by each wiper is in the shape of a sector, and the radius of each sector is, length of each wiper is r equal to 25 centimeter, and angle of sector is x degrees is equal to 115 degrees. Now area of each sector is x by 360 into pi r square and is equal to 115 by 360 into pi is 22 by 7 and r is 25. So by simplifying this value, we get 627.5. So area of one sector is 627.5, and now area cleaned by two wipers is 2 into area of each sector. That is 2 into 627.5, which is equal to 1255. So the total area cleaned at each sweep of the blades is 1255 centimeters square. Just we have to observe in this problem that the area swept by each blade is in the shape of a sector. That's all. Okay. After that, we can easily find the area of sector and the area cleaned by each sweep of the blades. Okay, students, that's all for today. And in next class, we shall solve remaining problems in this exercise. Until then, see you. Bye.